Well, in this learning session, we'll be learning the solutions or the answers for the examples of exercise 10.1 circles chapter of 10th NCERT CBSE textbook. In the first question here, the statement is a circle can have infinite tangents. Is it true or false? A circle can have infinite tangents. Definitely a circle can have infinite tangents because a circle is a set of points and to every point a tangent can be drawn, and therefore a circle can have infinite tangents. The second question asked here is fill in the blanks. A tangent to a circle intersects it in only one point. A tangent to a circle intersects it in only one point. Therefore the correct answer will be only 1 point or 1 point. A line intersecting a circle in 2 points is called as a secant, and definitely correct because the secant cuts a circle in 2 distinct points. A circle can have 2 parallel tangents to a given secant. So if a secant is drawn in a circle, definitely a secant can have 2 tangents which are parallel to it, and the correct answer is 2 in the to fill in the blank there. The common point of a tangent to a circle is called point of contact. Remember, the point where the tangent touches a circle is known as point of contact. In the question number 3, we are given radius of circle is 5 centimeters, PQ is a tangent, P is a point of contact, OQ is 12 centimeters. We have to find length PQ. So let us draw the figure for this and then understand. So we are given a circle with center O. O is the center of the circle, OP is the radius, and OQ is 12 centimeters, and PQ is the tangent touching the circle at point P. Now we have to find out the length of the PQ. That we have to find PQ in this. I think that is what is asked. So we have to find length PQ, and that is correct. So now in triangle POQ, as you know that OPQ is 90 degrees because the radius and the tangent at the point of contact are perpendicular to each other. Therefore angle OPQ is 90 degrees. So in the that means triangle POQ is a right angle triangle, and you are applying Pythagoras theorem for this. We get OP square plus PQ square. OP square plus PQ square is equal to OQ square, or PQ square is equal to OQ square minus OP square. That is 12 square, that is 144 minus 25, and that is 119, and therefore PQ will be square root of 119 centimeters. So that is how the answer can be found out. Therefore the correct answer or the choice of the answer is D in the choice given there. Now coming to example number 4, we are given a circle with center R, and also we are given a line. Now we have to construct a line, and also we have to construct a secant and a tangent parallel to the given line. So let us understand this. See, now we are given a circle with center R here, and also we are given a line PQ. Now we have to construct a tangent which is parallel to PQ to the circle, given circle, and also we have to construct a tangent that is tangent which is parallel to the given secant and also the given line PQ. And therefore we find here we have a circle with center R, PQ is the line, A, M and B is the secant because the line AB is cutting the circle in 2 distinct points M and N, and also it is parallel to PQ, and therefore the secant is parallel to PQ. And also we have a tangent here, COD. It is touching the circle in one point, that is point O, and COD is also parallel to PQ. In fact PQ, which is the line given, the secant drawn, that is AB, and also the tangent drawn CD, are all parallel to each other. Therefore PQ is parallel to AB is parallel to CD, and that is what is the construction. And I believe that you all know how to construct parallel lines. Therefore I have constructed the 2 lines, the secant, the tangent parallel to PQ here with to the circle, that and a circle also with center R. So try to understand this. If you have any doubt in this, you can comment. I'll give the clarification. Okay. Now coming to the next exercise here, that is again the exercise on circles only of 10th NCERT CBSE textbook, exercise 10.2. In the first example here, we are given from a point Q. That means that we have a circle with center O. From a point Q outside the circle, the tangent is drawn, that is QP is the tangent drawn to the circle, P is the point of contact, and R is the radius of the circle, and we have to now find out the radius of the circle. That means we are given the length of the tangent QP, we are given the distance of the point Q from the center O, and now you have to find radius. Now if you draw when you draw the figure here, you find that OP is the radius and QP is the tangent drawn to the circle from an external point, and therefore OPQ is 90 degrees because the radius and tangent at the point of contact are perpendicular to each other, and the distance of the point Q is 25 centimeters from the center. Now we have to find the radius. That means apply Pythagoras theorem to this right angle triangle, we'll get r square. Now r square is equal to here, that is OP square is nothing but r square only. So r square is equal to OQ square minus PQ square, that is 25 square minus 24 square, and that is 49. The OP square is 49, or OP is equal to square root of 49, and therefore OP is 7 centimeters, therefore radius is 7 centimeters. A very simple example. Now let us go to the next example. We are given TP and TQ are the tangents drawn to a circle from an external point. So we have got a circle center O, TP and TQ are the tangents drawn to the circle from an external point T. Angle POQ is 110 degrees. Now we have to find angle PTQ. So very simple. Now you see, if you look at this, the figure, TP is a tangent drawn from an external point, therefore the P is the point of contact, OP is the radius, therefore the angle OPT is 90 degrees because the radius and the tangent at the point of contact are perpendicular to each other, and for the same reason OQT is also 90 degrees. Now POQT is a quadrilateral. In a quadrilateral, angle P plus angle Q is 180 degrees, and therefore the remaining two angles, that is angle POQ plus PTQ, must be 180, and therefore angle PTQ is equal to 180 minus 110, and that is 70 degrees. A very simple example. So remember that. Now coming to the next example. Now given tangents PA and PB, we are given tangents PA and PB. P is the exterior point, so PA and PB are the tangents to the given circle with center O. Now the tangents are inclined at an angle of 80 degrees. The angle of inclination of PA and PB, that is total angle, is 80 degrees, and also now we have to find out angle POA. We have to find angle POA. So if you draw the figure, P is the exterior point, PA is the tangent, PB is the tangent, PO is the line joining from the exterior point to the center, and angle OAP is 90 degrees, OBP is 90 degrees because the radius and the tangent at the point of contact are perpendicular to each other. So we have two triangles here, that is we have triangles POA and POB, and by RHS congruency these two triangles are congruent because 90 degrees, radius and radius are equal, and OP is common to both. Therefore by RHS congruency the two triangles, that is POA and POB, are congruent. If they are congruent, corresponding sides and angles are equal. That means angle 3 is equal to angle 4, that is angle OPA and OPB are equal, and also angle POA is equal to angle POB. Now that means if angle 1 is equal to angle 2 and angle 3 is equal to angle 4, that means angle 3 and angle 4 will be half of angle 80 degrees, therefore angle 3 is 40 degrees, angle 4 also is 40 degrees. So we have got angle 3 is 40 degrees here. Now this is 90 degrees. So angle OAP is 90, angle OPA is what you call 40. So 90 plus 40 will be what you call 130 degrees, and the sum of the three angles of the triangle AOP is 180 degrees. Therefore angle POA will be 180 minus 130, and that is 50 degrees. So that is a very simple example again. Therefore angle POA is 50 degrees. Try to remember that. Now here in the fourth example, we have to prove that the tangent drawn at the ends of a diameter of a circle are parallel. That means we are given a circle with center O, and APB is the tangent, CQD is the tangent at the ends of the diameter. Now we have to prove that these tangents APB and CQD, which are drawn at the ends of the diameter QOP or QP, are both parallel. So let us understand how to do that. Let us go through the example again. Circle, we are given circle with center O, PQ is the diameter, and APB and CQD are the tangents, and P and Q are the points of contact of the two tangents. Now we have to prove that tangent CD and tangent AB are parallel, or rather we have to prove that CD is parallel to AB. Now CD will be parallel to AB if the co-interior angles are equal, and taking PQ as what you call as transversal. So let us understand that. Now OP is the radius, as you know that OP is the P is the point of contact of the tangent AB, okay, and OP is the radius. That means angle OPB is 90 degrees, and so also OQD is also equal to 90 degrees. And as you know, the radius and tangent at the point of contact are perpendicular to each other. Now PQ is the diameter, P and Q are the points of contact, and angle OPB is 90, OQD is 90. That means the angle what you call QPB and PQD, that is 90 plus 90, they form the co-interior angles, and PQ is the transversal there, and therefore when the co-interior angles are supplementary but natural, the two lines CD and AB are parallel to each other. Therefore the tangents drawn at the ends of a diameter are parallel. Remember that. Now coming to the next example, that is example number 5, we have to prove that perpendicular at the point of contact to the tangent to a circle passes through the center. To prove that the perpendicular at the point of contact, that is perpendicular which is drawn at the point of contact to the tangent to a circle passes through the center. Now what is given to us is circle with center O, APB is a tangent, P is point of contact, and when we join OP, then OP is perpendicular to APB, angle OPB is 90 degrees because the radius and the tangent at the point of contact are perpendicular to each other. Now let us consider here that there will be another point Q, that is let PQ be perpendicular, not OP, let PQ be perpendicular to APB at P. Then angle QPB is equal to 90 degrees, but we know that OPB is 90 degrees because OPB is also 90 degrees and QPB is also 90 degrees. But if you observe there very clearly, the whole angle is QPB, the part of that angle is OPB, and both are 90 degrees. Now that is a contradiction. That means it is impossible to have an angle which is equal and also be a part of the whole. Therefore our assumption that PQ is perpendicular to AB is not passing through O is not correct. PQ is perpendicular to AB but not passing. See, PQ is taken as perpendicular to AB but not passing through O is 100% incorrect assumption. Not passing through O is not correct, and therefore our assumption is totally incorrect. Therefore OP is perpendicular to AB and not QP is perpendicular to AB, because Q and O actually the points are coincident, and therefore the conclusion is the perpendicular at the point of contact, to the tangent to a circle definitely passes through the center O, and therefore PQ cannot be perpendicular to the tangent AB at P, it is only OP. Remember that. Now coming to the next example, we are given the length of a tangent as 4 cm, that means A is the exterior point, AP is 4 cm, and also the point A is at 5 cm from the center. That means the line, that is OA, is at 5 cm from the center of the circle. Now we have to find the radius of the circle. Again, very simple, apply the Pythagoras theorem here, because OPA is 90 degrees because the radius and the tangent at the point of contact are perpendicular to each other, and in triangle AOP we find that OA square is equal to OP square plus AP square. That means 5 square is equal to OP square plus 4 square, that is OP square is equal to 5 square minus 4 square, or OP square is equal to 9, and therefore OP is equal to root of 9, that is OP is equal to 3 centimeters. That is a very simple example. Now coming to the next example, we are given two circles C1 and C2 which are concentric circles with a center O, and the radius of the inner circle, that is smaller circle, is 3 centimeters and the bigger circle is 5 centimeters. Now AB is a chord which is in the outer circle and it is touching the smaller circle or the inner circle. So AB is a chord in larger circle touching the smaller circle at C. Now we have to find out the length of the chord AB. It's very simple again. OC is the radius of the inner circle, and also OC is perpendicular to AB because C is the point of contact of the chord AB, which is the tangent to the inner circle, and therefore angle OCA is 90 degrees. OA is the radius of the bigger circle, and therefore AOC forms a right angle triangle, and in this right angle triangle, if we apply the Pythagoras theorem, then we have 5 square is equal to 3 square plus AC square, or AC square is equal to 5 square minus 3 square, and that is equal to 16, and therefore AC is equal to 4 centimeters. AC is equal to 4 centimeters. Okay, so if AC is 4 centimeters, then AC plus BC, because we know that C is the midpoint of the chord AB and a perpendicular drawn to a chord bisects the chord, therefore AC is equal to BC, or AB is 2 times AC, and therefore if AC is 4, then AB will be 8 centimeters. So the length of the chord is 8 centimeters. So these were a few examples of the circles which we have learned. Please go through these examples again and again again. So we'll be learning the next exercise in our next video. Until then, practice this. But before you go for learning the solutions of these examples, learn the basics of circles, understand the properties of circles, understand the properties of chords, and all the basics of circles is required here to understand the solving of examples. Just learning a few examples wouldn't help. We have to learn the basics and apply those basics to solve more and more examples related to circles. Okay, so note on them in a book and keep them as a reference for your future use. Okay, thank you.